Welcome to our channel Electron Chemistry tutorial. I am Vijayalaxmi. Let us discuss objective bits from electrochemistry. Before that, let's see some important points from electrochemistry. Okay. See here. Electrochemistry gives the relation between electrical energy and chemical energy. Electrical energy and chemical energy. Means simply by using electric current we make the chemical reactions. So by chemical reaction we can produce electrical current or electrical energy. Clear? So this relation is studied in electrochemistry. Clear? Next, first of all, what is electric current? Electric current means flow of or passage of electric charges through conducting medium. The conducting mediums are maybe solids or liquids. Maybe the conducting mediums are solids, they are called electronic conductors. So they are liquids, electrolytic conductors. Okay. So simply electronic conductors, best example metallic wires. So electronic conductors nothing but aluminium wires, copper wires. Okay. So the next electrolytic conductors nothing but the substances which are in liquid state, they can allow the passage of electricity through them. So they are called electrolytic conductors. Okay. Electrolytic conductance. Simply here, conductance nothing but reciprocal of resistance according to Ohm's law. Okay. So electrolytic conductors also similarly electronic conductors, they obeys Ohm's law. Ohm's law. Okay. So that's why simply conductance nothing but we know very well reciprocal of resistance. But resistance is directly proportional to cell constant. Cell constant nothing but is the ratio of distance between two electrodes. And A means area of cross section of two electrodes. Okay. So simply that is cell constant. So that is equals to S into L by S means specific resistance, means resistivity. Okay. So this is also denoted as 1 by K means specific conductance. Okay. Now simply here C is nothing but instead of R we can write this one. So 1 by K into L by A means K is equals to C into what? L by A. Okay. So K means specific conductance. Simply conductances are three types: specific conductance, K, molar conductance, equivalent conductance. Okay. Specific conductance nothing but so conductance of a volume of solution or unit volume of a solution is simply known as specific conductance. Simply here, so conductance of a unit volume of solution nothing but see here by this formula. Here K is defined as the conductance of a unit volume of solution means L is equals to 1, A is equals to 1. So then we will get the conductance nothing but specific conductance. Conductance of a unit volume of the solution means conductance of a solution enclosed between two parallel electrodes. So it's separated by unit length, L is equals to 1, area of cross section A is equals to 1. So okay, so that is what specific conductance. Specific conductance units, conductance units ohm inverse. So here centimeter square, simply ohm inverse, centimeter inverse. So instead of ohm we can write in SI system Simon meter inverse. The next molar conductance. Simply here conductance of a unit volume of solution containing 1 gram mole of electrolyte enclosed between two electrodes separated by unit length and unit area of cross section. So they are called simply molar conductance, formula K into 1000 by molarity. 1 gram mole of solute. So that's why we can take molarity here. Equivalent conductance. So instead of 1 gram mole, here we can take 1 gram equivalent. Okay. So simply here, so 1 gram equivalent of electrolyte present in between two electrodes separated by unit length and unit area of cross section. Okay, so that is simply equivalent conductance. Okay, so simply here conductance is, so in electrolytic cell these are two electrodes separated by unit length, L is equals to 1. So this area of cross section means this area, length into width, so A is equals to 1, A is equals to 1. So here in that electrolytic solution, conductance, listen to me, conductance increases with the increase in its ions, its number of ions. Suppose for example here Na plus ions are present, so conductance C increases with increase in the number of cations and anions. Okay, but molar equivalent conductances are increases with increase in dilution. So means they are preferred for only weak electrolytes. So that's why as dilution increases, so the distance between the cations increases. Suppose weak electrolyte, you can take CH3COO minus H plus. So the distance increases, easily can break that bond, easily can form its ions. Means molar equivalent conductances increases with increase in its dilution. So remember, this is very important. Okay, so then suppose Huckel answer gives the relation between the equivalent conductance at given concentration at a zero concentration. So we can draw the graph here. So equivalent conductance at a given concentration, equivalent conductance at given concentration versus concentration, square root of concentration. So we'll get straight line with a negative slope. So this simply y is equals to mx plus c, no? Slope is minus a. Okay, so we'll get straight line with negative slope for strong electrolyte. So gradually the parabola, like parabola curve for weak electrolytes. Okay, so the next Kohlrausch law. Kohlrausch law is how to define. So it states that equivalent conductance at infinity dilution means almost zero concentration. So is equals to algebraic sum of conductance of cation and conductance of anions. Okay, so then simply this Kohlrausch is applicable for, useful for find out the, for calculate the conductance of weak electrolyte, equivalent conductance of weak electrolyte. Okay, suppose weak electrolyte nothing but organic electrolytes, organic solutions are weak electrolyte. Okay, so CH3COOH means conductance of cation, conductance of anion. Okay, so this is find out in the equation by what? Simply here I will write here, simply here conductance, suppose CH3COOH, acetic acid reacts with NaCl, gives rise to, will get acetic sodium acetate plus HCl. How to find out acetic acid? Equivalent conductance of acetic acid is equals to equivalent conductance of products minus equivalent conductance of reactant, remaining reactant. Okay, so by this way we can find out equivalent conductance for weak electrolyte. Okay, first we need to write chemical equation, then only we can arrange the order. So then only we will get what? Equivalent conductance of weak electrolyte, otherwise we will get wrong answer. Clear? Now, so this is also useful for the find out the degree of dissociation alpha, degree of dissociation of weak electrolyte, that is equals to, so equivalent conductance at given concentration, equivalent conductance at zero concentration, or equivalent conductance at given volume at infinity volume. Okay, so this is also useful for the find out the degree of dissociation constant K is equals to C into alpha square. Okay, so this formula is important, this one important. Okay, next electrolysis. Electrolysis, how to define? The decomposition of electrolyte. Suppose you can take any strong electrolyte here. Decomposition of electrolyte into its ions by passage of electric current. Okay, so it is known as simply electrolysis. So the decomposition, cation goes towards the cathode and anions goes towards the anode and discharge at the respective electrodes. Okay, so at anode oxidation takes place, loss of electron will get Cl2 gas. At cathode reduction takes place, addition of electron will get sodium. Okay, so simply, so how much percentage of this sodium or chlorine deposited or liberated at respective electrode, so is explained in the Faraday's laws. Okay, so according to Faraday's first law, how to define here? So mass of substance deposited or liberated or dissolved at respective electrode is directly proportional to quantity of electricity passed through electrolyte. Okay, so simply by deriving the equation, finally we will get what? M is equals to ACT by ZF. A means atomic weight of that element, current in amperes, time in seconds. So Z is equals to valency of that element, Faraday. F is equals to Faraday means charge on 1 mole of electron. Okay, so means that is 96,500 coulombs. How to get? Charge of 1 mole of electron, nothing but 1 mole, each electron charge 1.6 into 1.602 into 10 power minus 19 coulombs. 1 mole of electrons, nothing but 6.023 into 10 power 23. By multiplying this, we will get 96,500 coulombs. Charge on 1 mole of electron, nothing but Faraday. 1 Faraday. Second law, Faraday's second law. So Ma, if 2 or more electrolytic cells which are connected in a series, then if same quantity of Q is equals to 1, same quantity of electricity passed through different electrolytic cell which are connected in a series, then mass of substance deposited or liberated or dissolved at respective electrode is equals to its equivalent weight. Okay, so also its ratio. So Ma is equals to Ea, nothing but Ma by Ea is equals to Mb by Eb. Okay, clear? Next, here during the electrolysis, suppose here sodium chloride decomposes to give Na plus Cl minus ions, means at cathode only one cation, at anode only one anion. If more than one anions, cations present in the solution, means electrolyte, so then which will get discharged first? So which has a less discharge potential, that is discharged first. Okay, suppose for example you can take this example only. So I will show you clearly. Suppose aqueous NaCl you can take. So in that aqueous NaCl, nothing but along with NaCl it has water molecule. So NaCl decomposes to give Na plus ions, Cl minus ions. Water also decomposes to give H plus ion and OH minus ions. Okay, cations goes towards the cathode and anions goes towards the anode. Okay, so this is maybe cathode, this is anode. At cathode cations Na plus H plus, at anions Cl minus OH minus. So in that which is discharged first? So based on the discharge potentials, they are discharge simply cation discharge potential here. Lithium more discharge potential than the potassium, then the sodium, calcium, magnesium, aluminium, manganese. So then zinc, chromium, iron, hydrogen. Okay. So here sodium is there and H plus. Sodium H plus both are present. So which has discharge potential in this? NH plus. So that's why H plus, which has less discharge potential, that is discharged first. Okay. So that's why hydrogen discharged first when compared with sodium. Means first hydrogen takes electrons to give H2 gas. Okay. Next, so simply here 2 moles of hydrogen means 2 electrons H2. Okay. Next, here Cl minus, OH minus both are present. So anion discharge potentials, Cl minus, OH minus. In that Cl minus has less discharge potential, that's why that get discharged first. So that's why Cl undergo 2 Cl minus last 2 electrons to give Cl2 gas. Okay. So remaining ions, remaining which ion? Na plus OH minus ions combines to give NaOH. NaOH. Okay. So simply, so this is what electrolysis. Okay. So let's do some objective bits from these formulas, then go for remaining topic. Okay. See here first problem. A KCl solution conductivity 0.14 Simon meter inverse means K. Okay. So shows resistance R 4.19 ohms in a conductivity cell. If the same cell is filled with HCl, the resistance drops to 1.03 ohms. The conductivity of solution dash into 10 power minus 2 Simon meter inverse. Means simply here initially K1 specific conductance, R1 you can take here. So this is what R2, we have to calculate K2. Okay. So what is the relation between the specific conductance and resistance? Resistance is equals to 1 by specific conductance into L by A. Okay. So simply this is R1, K1. So R1 is given as how much? 4.19, that is equals to 1 by 0.14 into L by A. Therefore L by A is equals to how much? 4.18 into 0.14. How much? Okay. So then here suppose X is present. Then next for K2, R2 is equals to 1 by K2 into L by A. We have to calculate K2 here. So K2 value, for K2, K is equals to 1 by R2 into L by A. 1 by 1.03 into 0.58. So we will get 0.56 here. So that is equal simply 56 into 10 power minus 2. Minus 2 already given in the question. So then what is the value? 56 Simon meter inverse. Okay. Next problem, almost similar to first problem. So resistance of 0.2 m of electrolyte R1 is given as 50. So the specific conductance K1 is given as 1.4. The resistance of 0.5 m of solution of same electrolyte 280 ohms. Molar conductivity of 0.5 m solution. Means here molar conductivity, what is the formula? Mu is equals to K into 1000 by molarity. But we don't know K. For K, so here initially you can take R1 is equals to 1 by K1 into L by A. R1 is given as 50 is equals to K1 is given as 1.4 into L by A. So simply L by A is equals to 50 into 1.4. So that is what? 70. Okay. Next. R2 is equals to 1 by K2 into L by A. Now K2 1 by what? R2 value is given as second resistance 280 into L by A is 70. 7 1s are 7 4s are means 0.25. Okay. So K2 is nothing but 0.25. This K2 value substituted here. Then mu is equals to what? So why this K2 only substituted here? He asked the resistance of 0.5 m of the same electrolyte resistance R2 280, the molar conductance of same solution. So that's why we need to calculate K for this solution 0.5 ml solution. Then only that K value taken in the mu, this formula. Okay. Simply here 0.25 into 1000 by molarity is given as how much? 0.5. Okay. Tell me how much answer? 1s are 5s are. Simply 5 into 10 power 2. Okay. Next, third problem. The equivalent conductance of NaCl at concentration C and at infinity dilution given as lambda C, lambda infinity respectively. The correct relation between the lambda C, lambda infinity is given as simply Huckel-Hansager equation. What is Huckel-Hansager equation? So tau C is equals to tau naught minus A into square root of C, no? Okay. So simply tau C, instead of tau C he gave lambda C, that is equals to, instead of tau naught they give lambda C, minus instead of A they give B, simply C. This is the answer only. Clear? See your next problem. 2 Faradays of electricity is passed through a solution of copper sulfate. The mass of copper deposited cathode. So during the electrolysis of copper sulfate, copper plus 2 and SO4 minus 2 are formed. So at cathode what happened? Cu plus 2 takes 2 electrons and deposited as Cu. Okay. So this is what? Only 1 mole. 1 mole of copper deposited. To deposit 1 mole of copper, 2 moles of electrons, nothing but 2 Faradays. Okay. To deposit 1 mole of copper takes 2 Faradays of electricity. So 1 mole of copper, nothing but 1 mole of copper weight how much? 63.5 grams only. Okay. So 2 Faradays of electricity passed through CuSO4 solution. 63.5 grams of copper is deposited at cathode simply. Clear? That is the answer. Next problem. How long should water electrolyzed by passing through 100 amperes? 100 ampere current is given as 100 amperes current, so that the oxygen released can completely burn 27.66 grams of diboron. So simply what do you get? Diboron formula B2H6 completely burned in the presence of oxygen to give B2O3 plus water molecule. Okay. Clear? Yes. See here, diboron weight how much? 27.66 grams of diboron completely burnt by 3 moles of oxygen means 3 into 32 grams. Okay. So simply how long electrolyzed of water? Simply how long this reaction will take place? Means how much time takes to complete burning of B2H6 simply here. So what is that formula? We need to take Faraday's first law formula. M is equals to ACT by ZF. Okay. So M means how much weight of oxygen is required? 3 into 32 grams. Atomic weight of that oxygen, each oxygen weight 16 grams. Current is given as 100 amperes. Time we need to calculate. Z value, valency O minus 2, no, so 2. Faraday value we know very well, 96,500 coulombs. Then T is equals to 96 into 2, 96,500. Okay. Then 16 into 100. 2 zeros mutually cancelled. 1s are 8s are. Okay. By simplifying this, we'll get 11,580 seconds. So, but answer in hours. Simply T is equals to 11,580 seconds by 60 into 60. We'll get 3.2 hours. Okay. Seconds converted into minutes by 60. Per hours by 60. Okay. Next problem. 5 millimoles per decimeter cube of aqueous solution of KCl has conductance 0.55 milliseconds when measured in a cell constant 1.3 centimeter inverse. The molar conductivity is. So what is the formula of molar conductivity? Mu is equals to K into 1000 by molarity. Okay. So simply what is K? K is equals to conductance into cell constant. Okay. Here cell constant is given as 1.3. Conductance 0.55 millisecond, nothing but see here. 0.55 milliseconds means 55 into 10 power minus 2. Instead of milli you can take minus 3. Okay. So simply 55 into 10 power minus 5 into 1.3 cell constant. 71.5 into 10 power minus 5. Simply this K value substituted here. Mu is equals to K into 1000 by molarity. K is given as simply K is calculated as 71.5 into 10 power minus 5 into 10 power 3 by molarity. Millimole means 5 into 10 power minus 3 moles per liter means decimeter cube. Okay. How much? Simply 143 Simon meter square mole inverse. Okay. Clear? Next problem. Molar conductivity is a definite dilution of barium chloride, sulfuric acid, hydrochloric acid are 280, 860, 426 centimeter square mole inverse respectively. The molar conductance of barium sulfate at infinity dilution. Okay. Simply what is the formula? Simply here. Before going to that, write down equation. Barium sulfate reacts with HCl to give barium chloride and sulfuric acid. Barium chloride and sulfuric acid. Okay. Now see here. Molar conductance of barium sulfate is equals to molar conductance of products minus reactants, no? Barium chloride plus molar conductance of H2SO4 minus molar conductance of how many moles? 2 moles here. 2 into molar conductance of HCl. So molar conductance of barium chloride is given as 280 plus H2SO4 860 minus 2 into 426. By calculating this, we will get 288. The molar conductance of NaCl, HCl and Na. Okay, are 126.4, 425.9 and 100.5 Simon centimeter respectively. If the conductivity of 0.01 m molarity of HA is 5 into 10 power minus 5 Simon meter inverse, degree of dissociation. So what is the degree of dissociation? Alpha is equals to tau c by tau infinity. Okay, so for tau infinity, first of all we have to calculate tau infinity. So for tau infinity, so we have to write a reaction HA plus, so this HA reacts with NaCl, gives rise to NaA plus HCl. So tau infinity is calculated as, tau infinity of HA is calculated as tau infinity of NaA plus tau infinity of HCl minus tau infinity of NaCl. Okay, so Na, so what is this value? NaCl value 126.4, next HCl 425.9, so then NaA 100.5. Okay, so by simplifying we will get 400 here. Okay, so then tau c, calculate tau c. Molar conductance at given concentration, given concentration, so is equals to K into 1000 by molarity. K is given as 5 into 10 power minus 5 into 1000, nothing but 10 cube. Molarity is given as 10 power minus 3. Okay, so we will get what? 5 into 6, so means 50. Okay, 10 power minus 5, 10 power 6, now 50. So simply here alpha is nothing but tau, molar conductance at given concentration by molar conductance at infinity, dilution. So tau infinity how much? Tau c how much? 50 by 400. 1 za 8 za, 1 by 8 nothing but 0.125. Simply 1.25 into 10 power minus 1. Clear? Next, a solution of nickel nitrate is electrolyzed between platinum electrode using 0.1 Faraday of electricity. How many moles of nickel will be deposited? First of all, write down equation. Nickel nitrate decomposes to give nickel plus 2 plus NO3 minus. So we will talk about nickel plus 2. At cathode, nickel plus 2 takes 2 moles of electrons, means 2 Faradays of electrons, 2 Faradays of electricity. 2 moles of electrons or 2 Faraday of electricity taken by 1 mole of nickel to deposit 1 mole of nickel at cathode. So this is what 1 mole. Simply by using 2 Faraday of electricity, deposit 1 mole of nickel. 1 mole of nickel. By using 0.1 Faraday of electricity, how many moles deposited? Very simple, cross multiply 0.1 into 1 by 2. How much? 1 by 2 into 10 power minus 1. 0.5 into 10 power minus 1 means 0.05 moles of nickel deposited by passing 0.1 Faraday of electricity. Clear? Next problem. The products obtained at cathode and anode respectively during the electrolysis of aqueous K2SO4. aqueous K2SO4 means it contains water molecules also. Okay, so this K2SO4 decomposes to give 2 K plus ions, SO4 minus 2. So this H2 also decomposes to give H plus and OH minus ions. At cathode, what, how many ions are present? 2 K plus ions and H plus ions. So in that which has the least discharge potential value? So H plus has the least discharge potential. So that's why it get discharged first. So means H2 takes electrons to give H2 gas at cathode. So then next at anode, which ions are there? SO4 minus 2 and OH minus. So which has least discharge potential? OH minus ion. So it get discharged first. Okay. So discharged first. So OH minus ions give O2. So by loss of electrons to give O2 and H plus ions. Okay. So at cathode which is liberated? O2. So at cathode and anode means H2 comma O2 are liberated. Okay. So you have to recollect order of discharge potentials, then which is discharged first. So which has least discharge potential, they are discharged first simply. Okay, clear? Next, 11th and 12th. So this 11th, 12 questions you have to done, ma. So I will give you into. So the amount of current in Faraday's required for the reduction of dichromate ion into chromium ion. So how many Faradays are required? Simply I will give you equation for that int gives rise to Cr plus 3. So means 2 moles, no? 2 moles. So find out oxidation number of here chromium plus 6. So here 2 into plus 6, here 2 into what? 3 means 6. So how many electrons transferred? 12 minus 6. 12 minus 6 means 6 electrons. 6 moles of electron transfer, nothing but how much Faradays? So you have to do that. So only single step you have to do. Okay. The next, conductivity of 0.01 moles per liter of KCl. This much. This is what K value. This is molarity value. So molar conductance formula K into 1000 by molarity. So molarity is given, K is given. So you have to calculate molar conductance. Okay. So just you have to do it, ma. Okay. That's all for this video. Remaining topic we will discuss in next video. Thank you for watching this video. So please like, share, subscribe my channel to get more videos. Thanks a lot.